Hello students, welcome to this series of tutorials where we revise one chapter in 1 hour. So we've already covered the first chapter, number systems. Today we are picking up the second chapter, polynomials. Let's get started. So let's quickly look at the things we already know. We have studied these things in the last class, in the previous classes 9, 8 and 9, all right. So the general form of a polynomial is given as something like this. Let us look at what are the elements of this general form. Well, uh, for something to be a polynomial, one of the requirements is that all its terms must be of the form a x to the power n. All the terms, okay? Even the constant term is of this form. I'll show you how. So all the terms have to be of this form. I'm sure everyone knows what terms are. Terms are parts of an algebraic expression that are either separated by a plus sign or a minus sign. Those things are terms. And each term of an algebraic expression, if it's of this form, then it's a polynomial. Then there are ways to classify a polynomial. We classify polynomials based on how many terms are there in that polynomial. We also classify them based on the degree. What is the degree of a polynomial? We're going to look at those things also. First, let's look at this general form. This is called the general form or the standard form of polynomial. Okay. Now, all the terms must be of this form. So let's quickly check if it is actually true. An, where an is a number, okay, it's a number, and x is the variable, and n is the index or the exponent. This n must be an integer, or not just an integer, must be a natural number or a whole number. So it must be a whole number. Okay. So first term is definitely of this form, we can see that. The second term, this is some other number, okay? That's why it's written a n minus 1, okay? That's a way to represent a different number than a n. Again, we see there is the variable there, and also there is some exponent. You can see the exponent here. Okay, this is the exponent, and this is also the exponent. Similarly, here you have the exponent 1. This is also the exponent, and so on. So, till the second last term, we all can very easily see that all the terms are of this form, a x to the power something. What about the last term, the constant term? Well, this is also of that form. How? Let's see. Let's say this is a number, okay, a naught. Can I write this last term as a naught x to the power 0? Can I write it like that? Of course, I can write it like that because x to the power 0 is nothing but 1. So, from here we can see that the last term or the constant term is also of this form. So, this is all about the general form of the polynomial. Let me clean up. So, once again, this is how we write the general form, where the powers of x are written one after the other, and the highest power, the term containing the highest power of x, will be written at the start. Then slowly, the powers of x will reduce, and they'll ultimately reduce to x to the power 0. This is the general form of a polynomial. Let's move on now. As I told you, that there are two ways in which we broadly classify polynomials. One is based on the number of terms that are there in a polynomial. The second one is based on degree. Now, based on the number of terms, we'll keep it aside. That's not very relevant in today's session from the perspective of your board exams. But still, just a quick recap. If there is only one term in a polynomial, only one term, that means it's a monomial. Two terms, binomial, three terms, trinomial, and so on. Based on degree also, we classify polynomials. If the degree is 0, if the degree of a polynomial is 0, it's a constant polynomial. If the degree is equal to 1, it's called a linear polynomial. If the degree is 2, it's called a quadratic polynomial. Similarly, if the degree is 3, it's a cubic polynomial, degree is 4, quartic, degree 5, quintic polynomial. Okay, you don't have to remember all the names, just remember till cubic and you should be fine. Okay, but what is the degree of a polynomial? Do you recall? Do you remember what is degree of a polynomial? Degree is the highest power of the variable. As we know that in a polynomial there are multiple terms, okay? Let's say there are 3-4 terms in a polynomial, 3 to 4 terms. Now every term will have a variable, and that variable would have been raised to some power. So every term will have a degree. What is the degree of the entire polynomial then? The degree of the entire polynomial is same as the degree of that term which has maximum power on the variable. Let's understand this with the help of an example. Let's say we have 5x square plus 3 minus 12x to the power 4. This is a polynomial p of x. And if someone asks, what is the degree of this polynomial? Can you tell me the degree of this polynomial? Pause the video and think for a while and then tell me your answer. Yes, the degree is 4. How did we know that? See, first we'll calculate the degree of individual terms. So 5x square, it has a degree 2. This constant, this number has a degree 0. This term minus 12x to the power 4, it has a degree, okay? So it has a degree 4. Now every term has a different degree. So what is the degree of the polynomial p of x? What is the degree of this entire polynomial p of x? The degree of this entire polynomial is the basically the degree of that term which is highest. In other words, the highest degree of term of a given term in a polynomial is same as the degree of the polynomial. Let's move on. Okay, I hope everyone understands degree. So I'm going to clean this up. And one more purpose of showing you this slide was to show you how these polynomials look on the graph paper. See, you will be required to plot some of these polynomials, especially the quadratic polynomial on the graph. That's in your syllabus and it might come in the exams also. So you should know how all the other polynomials look like. A constant polynomial is very simple. It's just a straight line. Let's say this is some 2 units, okay? So this constant polynomial, you can represent it by p of x, f of x, g of x, h of x, whatever. Choose your alphabet. Here, this constant polynomial is represented as f of x. So f of x equal to 2 would look like this, okay? What about this linear polynomial? This linear polynomial, let's say it's something as x plus 1. Let's just say it's something like that, okay? It may not be exactly this, but this polynomial is represented by this line. I'm going to draw it with yellow. This is the graph of a linear polynomial. This is how the graph of a linear polynomial looks like. Let's look at the quadratic polynomial. It's a U-shaped graph like this. It has a special name. It's called a parabola. So if someone asks you how is the graph of a quadratic polynomial, it's a parabola. What is it called? It's a parabola. Okay. A cubic polynomial looks like this. A quartic and quintic polynomial look like these as given here. Just have a look at it, absorb it, and we'll move on. Okay, moving on. So let's quickly revise what is the value of a polynomial. We have a polynomial here, x cube plus 2x square minus 5x minus 6. It's represented as p of x. X can be considered as an input, okay? Input. So if someone asks you, give me the value of p of 2, what would you do? Wherever you see x in the polynomial, you substitute 2 there. So this will become 2 cubed plus 2 into x square, that means 2 square, minus 5 into 2 minus 6. You calculate this value, whatever number you get, that would be your answer. Okay. So this means we have found out the value of a polynomial p of x when x is equal to 2. This would give you the value of polynomial. Let's calculate it. This is 8. We have 4 into 2. Again 8 minus 10 minus 6. Okay, so 8 plus 8 is 16. 10 minus 6 minus 16. So 16 minus 16, that would be 0. Alright. This, so if someone asks you what's the value of p of x at x equal to 2, it's 0. This is the value of p of x when x is equal to 2. I hope all of us understand this part. This is the value of p of x when x is equal to 2. Well, this is all about values. Okay, can you try a couple of exercises quickly? Can you tell me the value of this polynomial p of x when x is equal to 0? Please find that out. Find out the value of this polynomial when x is equal to 0. So the answer is going to be minus 6. The value of polynomial p of x at x equal to 0 is minus 6. Let me write that somewhere just for our reference. So p of 0, when you calculate it, it will come out to be this. Can you also give me the value p of minus, p of 1? Give me the value of p of 1. That means the value of p of x when x is equal to 1. You just substitute 1 everywhere, right? So 1 cube plus 2 minus 5 minus 6. So here you, I'll quickly calculate. This is minus 11 here, 1 cube plus 2. So 3 minus 11, right? That's minus 8. So that's the value. When x is equal to 1, this is what you get. Now, let's move on to 0 of a polynomial. What do we mean by 0 of a polynomial? Sometimes this term can be confusing, but we're going to learn it from the basics, from the fundamentals. Okay. 0 of a polynomial means that value of x, that value of the input, which makes the polynomial 0. I'll repeat once more. It's that input which makes p of x 0. That's what the 0 of the polynomial is. So look at this p of x, the first p of x we had, and tell me what is the 0 of this polynomial. We found out 3 values. We found out p of 0, we found out p of 1, we found out p of 2. So which value of the input made the polynomial p of x equal to 0? Which value? That value was x equal to 2. So here x equal to 2 is the 0 of this polynomial, the first one, okay, the 0 of this polynomial. Alright, now we have another graph here. See, the zeros of the polynomials can be identified from the graph also. But let us understand, what does 0 of a polynomial represent on graph? First, we'll understand that, okay? Now, it's very simple. 0 of a polynomial means those values of input that made the polynomial 0, right? So, if I have to find out the coordinates of this point, it will be minus 5 comma 0. Okay. And what is minus 5? It's the x coordinate, and 0 is the y coordinate, right? So x is your input, y is your polynomial, right? Do you see that at minus 5 this polynomial becomes 0 when the input, now this is some other polynomial, mind you, it's not the same as the first one, the left hand side, what we have, this is not this, okay, this is some different polynomial. Let's call it capital P, capital P of x, okay. Let me clean this up a little and then. So this is some other polynomial, capital P of x. What does the 0 of this polynomial look like on the graph paper? These are those points, these indicate those points which cut the x-axis. These represent the zeros of the polynomial. These represent the zeros of the polynomials. How? The first point, the coordinate of that is minus 5 comma 0. You see, when the input is minus 5, the value of the polynomial becomes 0. This is your capital P of x. Okay. Similarly, look at the second point. It's 1 comma 0. 1 comma 0. Look at the third one. It's 1, 2, 3 comma 0. In all the three cases, you see that when the input is minus 5, the polynomial becomes 0. When the input is 1, the polynomial again becomes 0. When the input is 3, the polynomial becomes 0 once more. So, how many zeros are there, by the way, in this polynomial p of x? How many zeros? Can you count the number of zeros? There are 3 zeros in total. What are those? Let me write that. There are 3 zeros. And what are those? Those are x equal to minus 5. So when you substituted minus 5 in place of x, you would get 0. The polynomial's value is 0. The other one is x equal to 1. And the third one is x equal to 3. So these are the 3 zeros of this polynomial. So in the first case, we were given the polynomial p of x is given to us, x cubed plus 2x square minus 5x minus 6. This was given to us. From there we figured out the 0 of the polynomial. Okay, that's one way. What if the equation is not given and instead of that the graph is given to us? Even then we can figure out the zeros of a polynomial. You just have to find out where that graph cuts the x-axis. That's all. Cuts or even touches the x-axis. Those points will indicate the 0 of a polynomial. So I hope this part is clear. Let's jump right into previous year's questions. There are some questions, some very, very important questions coming from this section. So pay attention. Here's a question. Pause this video for a minute, try this out, then come back and look at the solution. So let's look at the solution now. The question says, if x plus a is a factor of this polynomial, find out a. Now, if you remember in class 9, you studied factor theorem. It says that if something is a factor of something else, how do you find the zero of that polynomial? This will give you zero of polynomial as minus a. That would be the zero of this polynomial. How? Let's see how. This is a factor of this polynomial. That means this polynomial can be represented like this, yes or no? Think. If this is a factor, then it must be something like x plus a multiplied by something else, okay? X plus something something, I don't know. Okay, let it be. If this is a factor of this polynomial, can I represent this polynomial in this format? Yes or no? We can definitely. Okay. Now, we have to find the zero of this polynomial. At least one zero we can definitely find. Think, how can you turn this polynomial into a zero? What value of input should you choose so that this becomes zero? This is your input, right? What value of input will you choose so that this polynomial's value becomes zero? Try choosing input as minus a and see what happens. If you choose input as minus a, this term will become 0. 0 multiplied by anything is 0. So I didn't really need to know what is the other factor. If I have to find out just one 0 of this polynomial, I'll just choose this as the input and this will give me 0. This will make the polynomial 0. Okay, with this understanding, let's now solve this question. X plus a is a factor. That means x equal to minus a is a zero of this polynomial. That means when I put minus a inside this polynomial, wherever I see x, I'm going to put minus a. I should get the value 0. So when I do this, I must get a 0. That's what the question says. Okay, so I have an equation in front of me. Let's try to solve it and find out the value of a. It's 2a square minus 2a square minus 5a plus 10 equals 0. This will get cancelled, or we will have 10 equals 5 times a, or a's value is 2. So that's the answer. Okay. This is a 1 mark question. This is one of those types of questions that you are asked in your board exam. It came in 2008. Let's look at one more question from this section itself. It's also a 1 mark question, a slightly different looking question. Try this one. Pause the video, try this one, come back to see the solution. Okay, let's look at the solution now. It says if 1 is the 0 of this polynomial p of x, find out the value of a. If 1 is a 0 of this polynomial, this means whenever I put 1 in place of x, this polynomial would turn 0. This polynomial will become 0. Let me write it. When I put x as 1, p of x becomes 0. This is what is stated by this statement. This is what is given in the question. With this understanding, let's try to answer. Let's substitute x equal to 1 in the polynomial. We have this polynomial p of x as ax square minus 3a minus 1 times x. minus 1. So what would be P of 1? P of 1 would be a 1 square minus 3 into 1 minus 1, sorry, 3 into a minus 1. You have to put 1 in place of x, alright? So that's what we did. Now, let's simplify. P of x becomes 0, right? So P of x becomes 0. We'll write 0 there. And what we have is a minus 3a plus 3 minus 1. So this will give you 0 equal to minus 2a plus 2. This will give you a equal to 1. That's your answer. Okay. So let's look at one more question based on the zeros of a polynomial and values of a polynomial. Again, pause the video, try it out, and then come back to watch the solution. A very similar question as the last one. It says if one zero of this quadratic polynomial is 2, then what is the value of k? Same thing. That means if input is equal to 2, polynomial becomes 0. So let's input 2 first. Let's do that. K into 2 square plus 3 into 2 plus k. We have inputted 2 here. We have substituted 2 in place of x. If this happens, then the polynomial becomes 0. So then the polynomial becomes 0. This is your equation. You have to solve this, find the value of k, you get your answer. Let's quickly find out. It's 4k plus 6 plus k equal to 0. So it's 5k plus 6 equal to 0. K is equal to minus 6 upon 5. This is your answer. Okay, let's move on to the next question. This is one final question, so mostly you get 1 mark questions only from this section, but sometimes you do get 2 or 3 mark questions. So if you scan the last 10 years question paper, you're going to find mostly 1 marker questions from this section. Okay, here's one more. Do try this out and come back to look at the solution. Let's look at the solution now. Uh, we have to find, this time we have to find the zeros of the quadratic polynomial. Do you know how to find the zeros of a quadratic polynomial? Remember the factorization technique you learned in class 9 by splitting the middle term? That's what we're going to do here. We're going to split the middle term and find out the answer. Find out the zeros of the polynomial. So this is type 2 of the question. The first type of question that we saw was that if one of the zeros was explicitly given to you and they would ask you to find some unknowns. We solved 3 questions on that. And this is a different type of question where they give you a polynomial and ask you directly to find out the zeros. Now there are many different ways in which you can find that. So there is a hit and trial method, then there are direct formulae, then there is a splitting the middle term. This one is a very simple quadratic polynomial. We can split the middle term and factorize it. Let's do that. First thing is you find how many factors. You write some factors of this. Okay, so it's 2 and 3. Of course, 1 and 6 are also factors of this. Now, what 2 factors should I choose from here so that their product is 6? I can either choose 2 and 3 or I can choose 6 and 1. Clear? Okay. But which one? Which pair should I choose? There is another condition. See, whatever factors I choose, their sum has to be 5 or minus 5. So it would be better, see if I choose 6 and 1, that won't give me minus 5, right? Because their product is, remember to keep in mind the signs of every factor. Okay, so we have plus 1 multiplied by plus 6. That does give me plus 6 as the product. But if you add 6 and 1, you get 7. You don't get 5. Whereas if you choose plus 2 and plus 3, the product you get as plus 6. The sum you get as plus 5x. So plus 2 and plus 3 are not going to work here. Plus 2 and plus 3 are not going to work, but with a slight tweak, we will know the answer. Instead of plus 2 and plus 3, let's take minus 2 and minus 3. Now see, tell me what is the sum. If you add these two numbers, you get minus 5. See? And if you multiply these two numbers, you get 6 plus 6. So all the conditions are satisfied if I pick minus 2 and minus 3. If I split minus 5 as minus 2, minus 3. Okay? So with this understanding, let's split the middle term now. X square minus 5x plus 6. This becomes x square. Now I'm going to write minus 5x as something like this. Minus 2x minus 3x. I can do that, right? Now this kind of splitting is going to help me factorize this polynomial. And once I factorize this polynomial, I can easily find its zeros. So let's see. Uh, in the first two terms, I'll take x common. I get x minus 2. Then in the next two terms, I'll take minus 3 common. Again get x minus 2. Now I'll take this thing common from both the terms. This becomes x minus 2, and what is left is this minus this. So x minus 3. So I have been able to, excuse me, so I've been able to factorize this polynomial now. But we had to find the zeros of the polynomial. So we had to find when does this polynomial become 0. When does this become 0? This will become 0 when the input is either 2 or 3, right? So if instead of x, if I put 2, this term will become 0, making the entire polynomial 0. If instead of this x I put 3, I'll get 0 again. So 2 and 3 are the zeros of your polynomial. You have found your answer. Okay. Let's move on to the next section, which is understanding the geometric meaning of zeros of the polynomial. We did do a short discussion on this. What do we mean by zeros of a polynomial if we have a graph? Now here we are going to concentrate on quadratic polynomial. Well, it was mentioned earlier that a quadratic polynomial is represented by a parabola on the graph paper. But why should you assume this? Why should you believe this? Do you have a proof? Or can you verify that a quadratic polynomial always represents a parabola? You can basically. So the very crude way of doing this would be to just plot the points. Let's say someone gives you an equation y equal to 4x squared. Okay, it's a quadratic equation because it's a quadratic polynomial because the highest degree is 2. So you try plotting this on the graph paper, alright? You try plotting this on the graph paper, you'll find that you're getting some graph like this. You pick any parabola, try plotting. How do we plot? We choose different values of the independent variable. That means you choose x equal to 0, x equal to 1, x equal to 2, x equal to 3, and so on. You will get corresponding values of y. So once you have the xy pairs, you can plot those points on the graph paper. Plot those points on the graph paper, join all those points. Once you do that, you will get a parabola. There is no other way. Okay, whichever quadratic polynomial you pick, you always will get a parabola. Sometimes you might get an upside down parabola. Sometimes you might get a parabola just touching the x-axis. Sometimes you might get a parabola crossing the x-axis and so on. But you will get a parabola. There is no other way. Okay, with this understanding, now we are going to look at something very important which is going to help you in your exams. See, by looking at the graph of a quadratic polynomial, you can know many things about it. Things like this. If the graph has a parabola opening upwards, something like this, okay? If you have a parabola, something like this, that means A must be positive. Okay, a positive A will give you an upward pointing parabola. So this is what it means. And when you see something like this, for this the value of A is less than 0, it's negative. So if in a question they give you a quadratic polynomial and ask which of these graphs represent that polynomial, you can discard two options just like that, okay? Because two of those would be upward pointing, two of those would be downward pointing, and so on. So that's just one thing which we can know from the graph. There are many other things, by the way, okay? So we now know that if it opens up, then the coefficient of x square must be positive. If it opens down, if it's like this, opening down, then the coefficient of x square must be negative. This is known to us. All right. If we have a wider parabola, let's say opening up but wider, that means the coefficient is smaller. If we have a narrower parabola like the red one here, if we have, okay, let me use red color. If we have a narrower parabola like this one, that means the coefficient of x square is bigger. Why bigger? It simply means that y, the value of y increases very fast. So let's try to compare y equal to x square and y equal to 10x square. Okay. A slight change in the value of x in the second equation will shoot up the value of y very rapidly. And that's why 10x square will be represented by this graph, the narrower parabola. Okay. So these are the two things. It's going to help you in calculus also when you learn about transformation of graphs and functions. So yeah, do make a note of these things. All right. Now that we know that a polynomial, quadratic polynomial specifically, represents a parabola, can we spot the zeros of this polynomial? Let's look at this second picture. It's taken from your NCERT textbook. We have a parabola. The equation is also given. The equation of the parabola, or you can call it the quadratic polynomial, is also given. You have to spot zeros of this polynomial. For now, just tell me how many zeros are there in this polynomial. Just tell me how many zeros are there in this polynomial. I'm talking about the second picture. This one. How many zeros? So, in simple words, I'm asking at how many places is p of x or the value of y becoming 0? In how many places the value of y is becoming 0? See, y is 0 here. So at this point y is 0, at this point y is 0. There are two zeros of the polynomial. In fact, you can find out what exactly those two zeros are looking at this graph. So if your input is -1, the value of y becomes 0. If the input is +4, the value of y becomes 0. So what are those two zeros of the polynomial? Those two zeros are -1 and +4. These are the two zeros of this polynomial. I hope the geometric meaning of zeros of a polynomial is clear. Yes? Okay. Moving on. The type of questions that you get in the board exam relating to this topic is given to you. So mostly you get questions on identifying how many zeros are there in a polynomial. So can you tell me how many zeros are there in the first polynomial? See, it's cutting the x-axis at 2 points, so 2 zeros. In the second one, how many zeros? It's touching the x-axis at only 1 point, so only 1 zero. Only 1 zero. Look at the third picture and tell me how many zeros are there. If you look at it, this parabola doesn't even touch the x-axis, forget about cutting it. So actually there are no zeros in this quadratic polynomial. No zeros. This strategy is working with quadratic polynomials, but it's not limited to that. This strategy of counting the zeros, of counting the number of zeros, also work with cubic polynomials, quartic polynomials, pentic polynomials, and so on. Okay, it works with all the functions. All right, here's a little recap question for you. This one. Try answering this. Let's say we have a graph. Let's say that we have a polynomial of degree 5. It will intersect the x-axis at most how many points? See, it can intersect at 0 points, 1 point, and so on. But at most, what is the maximum that it can, what is the maximum number of points that where it will cut the x-axis? This is something to remember. Whatever the degree, those many number of points. At most 5 points. Okay, if the degree is 5, at most, at maximum, it's going to cut it at 5 points. All right. With this, let me quickly refresh your memory about transformation of graphs also. Can you tell me whether the coefficient of x square, so y is equal to ax square plus bx plus c. This is the general form of our quadratic polynomial, this part. Can you tell me, in the for the first graph, is a positive or negative? A greater than 0 or a less than 0? What do you think? What should be the value of a? Well, at least what should be the sign of a? This parabola is opening downwards. That means a must be negative. Negative a. So what would be the sign of a in the second one? Here a would be positive. In the third one also a would be positive. Okay, so the coefficient of x square, this is how you can figure out whether it is negative or positive. Here's a previous year question from this section. Usually you get such questions from this section, okay? So very simple, very easy ones. Try this out, okay? Let's look at the solution. So to find the number of zeros, you just have to count at how many places is this polynomial, is this graph cutting the x-axis. It's cutting at 3 places, so the answer is 3 zeros. That's it. Okay. Let's look at the relationship between zeros and coefficients of a polynomial. We're going to start with a linear polynomial. A linear polynomial, the general form is ax plus b. This is our linear polynomial. If we have to find the zero of this polynomial, the zero of this polynomial, how do we do that? You just equate it to zero, right? You just equate it to zero, find the value of x. You get it. You do this and then tell me whether this statement that is given to you here, this statement, is this right or wrong? You find out the zero of this linear polynomial and tell me, are the zero of a linear polynomial, or is the zero of a linear polynomial related to its coefficients? These are the coefficients. A and B are the coefficients. If you find zero of this polynomial, you'll find x is equal to minus b upon a. This is what you'll get. Isn't x, or this is your zero of the polynomial, right? You can see that the zero of the polynomial is definitely related to the coefficients, right? We all can see that the zero of the polynomial is related to the coefficients. My next question is, does this relation also occur in quadratic polynomials, quintic polynomials, cubic polynomials, quartic polynomials? Does this happen? Yes or no? That's what we're going to find out. In fact, you are going to find this out yourselves. Okay, I'm not going to just tell you that there is some relation, you should remember that. No, you have to experience this. So, here's a question. We have a polynomial. Why don't you factorize it first and find the zeros? So, this is your question. Find its zeros. Find the zeros of a polynomial. You know how to do this. Okay, let me quickly do this for you. So 2x square minus 8x plus 6. You split the middle term. 2x square minus 2x minus 6x plus 6. You take 2x common, you get x minus 1. You get minus 6 common, you again get x minus 1. X minus 1 and 2x minus 6. These are the two factors, and from here you get x equal to 1, or 6 upon 2, that's 3. 1 and 3 are your zeros. Okay, once you have found out the zeros, now tell me this. Can you tell me what is the sum of these zeros? Do 1 plus 3. This is the sum, right? That's the sum of the zeros, right? Sum of the zeros is this plus this. It's 4. Oh, also tell me what is the product of the zeros. What is the product of the zeros? 3 into 1 is equal to 3. So we have the sum and product. Okay. Now, our original question was, is there a relationship between zeros and coefficients of a quadratic equation? We know that the coefficients are 2, minus 8 and plus 6. These are the coefficients. So, do the roots or the zeros of the polynomial, they have any relation with the coefficients or not? So if you observe carefully, it turns out that there is indeed a relationship. And what is that relationship? The sum of roots that you found out, look at this. So 1 plus 3. This was the sum of zeros. So 4. And look at minus b upon a. What you get? Negative coefficient of x, that means minus of minus x, that becomes, minus of minus 8, that becomes plus 8 upon coefficient of x square, which is 2. Wow. So alpha plus beta, or the sum of the zeros, is coming out to be same as minus b by a. Alpha plus beta is coming out to be the same, exactly the same as minus b by a. Similarly, alpha and beta, the product of alpha and beta will come out to be equal to c upon a. You can check that, you can cross check that. Product was 3, and what is the value of c upon a? The constant term, which is plus 6, divided by the coefficient of x square, which is 2. That this is plus 3. So see, same. So yes, there is a relation between the zeros and the coefficients of a quadratic polynomial also. There is a very similar relation for a cubic polynomial also, for a quartic polynomial also, for a pentic polynomial also. We are going to look at that, okay? We are going to brush through those concepts also. But first, let's try a question on this relation. So I would request everyone to try this out. Take 5 minutes, try this out on your own, then come back to look at the solution. Okay, I hope everyone has given it a try. Let's see how to solve this. See, one of the standard forms of a quadratic polynomial is also written as this: x square minus sum of roots. So I will just write it as s, okay? S means sum of roots plus p, where p is the product of roots. I'm going to label these now. This is sum of zeros, you can call it right now. Okay, when you have a quadratic equation, then we call them roots. When we have a quadratic polynomial, we call them zeros. That's all the difference there is between zeros and roots. You can use it interchangeably also, but the technically correct term is zeros in this place, okay? P is the product of zeros. Both of these quantities are known to us. Remember, this works when this coefficient is 1. Okay, the coefficient of x square is 1. Okay. Sum of zeros, it's 6, it's given to us. So now I'm going to write down the final equation. It's the final polynomial. X square minus the sum is 6. So 6x plus the product is 4. That's it. This is our polynomial. So simple. That's why it's a 1 mark question. Let's move on to the next one, okay? Next one is a little bit tricky. It's a 2 mark question, but I'm sure you can find this out. Try it out, then come back to look at the solution. Let's look at the solution of this question. First of all, whatever polynomial is given to us, we're going to modify it slightly so that the coefficient of x square is 1. And how do we do that? 6x square plus 37x minus k minus 2. This is the polynomial given to us. It's p of x. Let me divide p of x by 6. And why I'm doing this? So that the coefficient of x square becomes 1. So 37 upon 6x minus k minus 2 upon 6. So this is what I get. You can call this another polynomial q of x, no problem. Okay. Now, It's given that 1, 0 of this polynomial p of x is the reciprocal of the other. That would be true for q of x also. Let's say that 1, 0 of the polynomial is alpha. Okay, let's assume that the two zeros are alpha and 1 upon alpha. Then what is the product of these two zeros? You can multiply and see, it's 1. Okay, alpha into 1 upon alpha is 1. And if you look closely, look at the last problem we did. The constant term actually gave us the product, and this was only true when the coefficient of x square was 1. So if this entire thing is same as the product, can I write something like this? Minus k minus 2 upon 6. Can I write something like this? I can write it, right? Okay. From here you get the value of k. So here's how you get the value of k. I'm writing in this place. So we've just got that minus k plus 2 is equal to 6. This is what we know. So k is equal to 2 minus 6, which is minus 4. That's your answer. That's your answer. Okay. Okay, so here's a 3-mark question from last year board exam paper. Try solving this, okay? Take 5 to 10 minutes, attempt this question at least once, and then only come back and look at the solution. Pause the video and attempt it once. Alright, so let's look at the solution now. Alpha and beta are the zeros of a given polynomial. That's given to us. We have to find out another quadratic polynomials with roots these. X square minus 5x plus 6. So can you tell me what is the sum of roots of this polynomial? It's minus of minus 5. That means this we are getting from the relationship between the coefficients of a polynomial and its roots. So minus b by a would give you this. And what would be the product? It's c by a. So that means 6 upon 1, that's just 6. Okay. So if we have these two quantities, it's really easy to find out the second quadratic polynomial. It's really easy. I'll show you how. See, can you find out the sum of these two roots? What is this? Let's see. Let's take the LCM, alpha, beta in the denominator, and here you'll have beta plus alpha. Okay. It's an interesting expression, but I know what is alpha plus beta, and I also know what is alpha beta. So this. So for the second quadratic polynomial, I've got the sum of its roots. Yes, I've got the sum of its zeros. Let's find the product of its zeros. So this is one thing which will help me frame the quadratic polynomial, the second one. And 1 upon alpha into 1 upon beta, that's 1 upon alpha beta, which is 1 upon 6. So you now forget about this polynomial, okay? You forget about this part entirely, this thing in the red box. You can forget about it. We just need to focus on the blue one. We have the sum of roots or the sum of zeros. We also have the product of zeros. So can we frame the quadratic polynomial now? We can. It's going to be x square minus sum of roots of, so sum of roots of this polynomial times x plus the product. This will give you the answer. Instead of s, you put 5 by 6. Instead of p, you put 1 by 6. So what would be the final answer? X square minus the sum of x. This is s, okay, s for sum. So minus sum times the x plus the product. So this would become x square minus 5 upon 6 x plus, what is the product? It's 1 upon 6. 1 upon 6. You can either leave it like this, or what you can do is you can multiply 6 with all the terms. That would also be a correct answer. So 6x square minus 5x plus 1. Either of these two would be correct. Okay, any of these two. Why either of these two would be correct? Because see, if you have to find out the zeros, you will ultimately have to equate it to 0. Now, if you equate it to 0, you will find out that both of these things are actually identical. Both are identical. Okay, moving on to the next section. So we have almost completed everything that is to learn in this chapter, quadratic polynomials. But polynomials don't just include quadratic polynomials, they include cubics also, quartics also, pentic polynomials also, and so on. But in our syllabus, at max, they are going to ask you about cubic polynomials. We saw that in linear polynomials, there was a relationship between the coefficients and the zeros of that polynomial. Same thing happened with quadratic polynomials also. Same thing happens with cubic polynomials also. The relation is a little different though. See, always remember this, the sum of roots, that is the first quantity you find out. The sum of roots is always going to be minus b by a. Always. For quadratic, for cubic, for quartic, for pentic, the sum of roots alpha plus beta plus gamma, because it has three zeros here. So the sum of zeros will always be minus b by a. And then sum of zeros taken two at a time. So alpha beta plus beta gamma plus gamma alpha. That's going to be c by a. Things start changing from here, okay? C by A, and then finally the product of roots, that's alpha beta into gamma, that's minus d by A. What's happening here? I want you to notice a pattern. The pattern is that plus and minus signs are alternating. Can you verify that? See, here we have minus sign, then here we have plus sign, then minus sign. It's alternating. From this observation, we are going to write a similar relation for quartic polynomials also. The first thing I told you, that the sum of roots is always going to be minus b by a, or the sum of zeros of this polynomial is always going to be minus b by a. So it's a quartic polynomial, so there would be 4 zeros. Let me call those as alpha, beta, gamma and lambda. Okay, let's say these are the 4 zeros of this polynomial. The sum would be minus b by a, no questions asked, always. Now we're going to take roots 2 at a time. All right, so what do we have? We have alpha beta plus beta gamma plus gamma lambda plus lambda alpha. Okay, this would be c upon a, taken 2 at a time. Sum of roots taken 3 at a time. That means uh, alpha beta gamma plus beta gamma lambda plus gamma lambda alpha, sorry, gamma lambda alpha plus lambda alpha beta. This is equal to, now the signs will alternate. So here we had minus, here we had plus, here again we'll have minus, and d will come next. So d upon a. And finally, we're going to have the product of alpha, beta, gamma, lambda. this is plus E upon A. So that's how the relation unfolds. Okay. Quartic polynomial is not in your syllabus, so you won't have to deal with this in your exams. I just told you this so that you can see the pattern when we move from linear to quadratic to cubic. There is a pattern. One pattern is that minus, plus, minus. These signs keep alternating. And then the first thing you should remember that the sum of roots is always minus b upon a, be it any kind of polynomial. The sum of zeros is always minus b upon a. So yeah, with this, we have covered everything that is there to learn in this chapter. Thank you so much for joining, students. I hope you enjoyed this session. I hope this helps you revise things fast. Thank you. See you in the next session.